So in our scenario, for example, PC A would like to communicate with PC B, then PC A must know about PC B identities, and those identities are MAC ID and IP address. So first let's verify on PC A whether the PC A has information about PC B or not. Well, to verify that information, all we can do is we can go to PC, go to run. In command prompt you can just type arp-a. So at this point we do not see any information here, because if it had, then we should have seen some information coming in here from PCB. Now let's try to understand what will happen if PCA does not have the information from PCB. So what is going to happen, since PCA does not know the identity about PCB, then PCA is going to send the broadcast. So what happens in the broadcast, basically PCA would like to know the identity of PCB. So what it does, it queries to all its connected port, but right now PCA only connected to switch. Now switch is also going to verify whether it also has this information or not. So let's have a look upon whether the switch also has this information or not. To do that, what we can do is we can go to switch and let's type show MAC address. As we can see, even the switch also doesn't have the information coming from any of the PC. So what it is going to do, it is also going to send broadcast traffic to all its connected port. For example, this PCB, PCC and the server. If you have hundreds of PC connected on the particular switch, then all hundreds of PC going to listen to this broadcast. So once this broadcast traffic is going to hear by all this PC, what the PCs are going to do, they're going to inspect the packet. So let's take an example with in case of PCC. So what PCC is going to do, it's going to open the packet and it will see the information. So what is the information going to come in the packet? So it is going to come the information which is source and destination. In the source, it's going to put the information which is coming from the MAC ID of the PCA, and it will the IP address of PCA as well. At the same time, it is going to be MAC ID which is going to be all F, because it is the broadcast traffic, plus it is going to be IP address which is belong to PCB. Since this information is not belong to PCC, PCC is going to simply discard this packet. Same is going to do by the server. Server is also going to discard this packet. But once it will receive by the PCB, PCB will inspect the packet and it will know the information belong to my IP address. So it is going to acknowledge back to switch, and then switch is going to have this information in its table, where it's going to create the table belongs to PCA and PCB. So it is going to create table where it will have the MAC ID coming from PCA as well as PCB and on which port they are connected. So we will see all this information in a moment. Well, to understand this in better way, let's go to simulation mode. So in simulation mode, what we're going to do, we're going to create a packet, let's say from PCA, we'll send the packet to PCB and we'll see what happens. So we are on PCA and let's send some packet, and in computer networking we basically send the ping request. So I'm going to use the ping request to PCB 192.168.10.12. it's an IP address of PCB. So once this packet is sent or the ping request is sent, let's see what happens. So now ping request is sent and the simulation mode, the packet is ready to go. Now let's play the simulation. So as we can see, the packet is came to switch in here, and let's see what happens. Now the packet has been sent to PCC and the server, but they are discarding the packet. But PCB has replied back to PCA. Now it came to switch and it's now came to PCA. So earlier we saw on the PCA it did not have the information from PCB, right? Now let's see whether the PCA has the information or not. Let's clear this out. Let's go to PCA. So I guess we need to stop simulation. So let's stop this simulation and we'll go to real time. We'll go to PCA. Now we can see some packets been also sent and we saw the replies coming from PCB. Now let's do the same command, which is arp-a. Now we can see the information coming from PCB and the MAC address, which is also belong to the PCB, which is 24B5, right? Now let's verify whether the switch also has this information or not. So if you go to switch and use the same command, show MAC address table, and we can see the MAC ID which is coming from PCB as well as coming from PCA. Question is, how would we know whether the broadcast was sent from PC or not? So let's go to simulation mode again. Okay, it's been clear. So let's generate the packet one more time. So for that, what we can do is we can just clear this MAC address table so that we will have the broadcast sent again. So we do the clear MAC address table. It's going to clear MAC ID, and on the PC we're going to do same thing. We're going to delete arp-delete, which is going to delete. If we do the arp-a, it's not going to have any information. So let's run the ping request one more time. Ping 192.168.10.12. okay, now the packet has been ready to go and it will come to switch, and from switch let's play the first. So packet is come to switch, and from switch it should go to all the computers. It is going. Now you can see it is discarding on PCC in here and as well as on the server. So PCB is going to reply back as we saw earlier, but our main goal is to understand whether the PC had generated the broadcast or not. So to know that, let's go to one of the packet which was generated earlier going from PCA to switch. So we can see in here the packet was sent from PCA to switch. Now let's see what are the information had in those packets. So we see here the information was contained the source MAC address which was coming from PCA and the destination MAC address which was the broadcast address, right? So this is the MAC address. If it is all F, it becomes the broadcast address. At the same time, it had the information which was source IP address which was belonged to PCA. The destination IP address was belonged to PCB. So when PCA wanted to communicate with PCB, it tried to communicate with the IP address, but it did not know the MAC address of PCB, and that is the reason it sent the broadcast. Well, we have one issue here because the broadcast is not a good thing. Let's say we have hundreds and thousands of computers connected in the network, and if all the PCs would like to send the traffic to other PCs, and if they are sending the broadcast traffic each and every time, then what will happen? There would be slowness on the application we are going to use. So how can we avoid this broadcast? Well, the answer is we cannot avoid the broadcast because the broadcast is important in order to know the identity of the PC. However, there is a workaround. The broadcast is only be going to send if it is like first time communication. But once the PC knows about the identities, the second time communication is going to be called unicast. Now let's try to see what happens since the PCA knows this information. So first let's verify whether the switch also has this information or not. So let's go to show MAC address table. Switch has the information about PCB and PCA. Now let's try to generate the packet again from PCA. So if we request for the ping again, since PCA knows about the location of PCB, let's see what happens. But let's verify whether PC has the information or not. It has. Now let's send the ping request, ping 192.168.10.12, and let's see what will happen in simulation mode. So in simulation mode, let's press this simulation play, and we can see the traffic is coming to switch and we are expecting to coming to PCB. So it is coming to PCB, but it's not sending to these PCs as we saw earlier. So this is basically a unicast, and it is going back to switch, and from switch it should come back to PCA. So that is how the broadcast and unicast work together. So if it is like first time request, it is going to be broadcast, but once the identity known by the PCs, it's going to be a unicast on second request. So in this case, PCA is not going to send broadcast if it is second time communication. It is going to send the request to switch. It's going to say, I would like to communicate with IP address which is 192.168.10.12 and also know about the MAC address of PCB, where the switch is trying to understand on which port these MAC IDs are actually connected. So as we saw, the switch also had information FA02 was actually connected for PCB, FA01 was connected to PCA. So it is directly going to send the information on FA02 to PCB. It is not going to send information to other PCs being connected. So far we discussed how communication happens based upon IP address plus MAC address. But we haven't discussed about the how the third identity is being used, which is called the host name. So let's try to understand how communication will happen if we try to communicate by using the host name.